When we design a fair test, which is what you're going to be doing in this experiment, we have to think of three things: the dependent variable, the independent variable, and the control variable. So to look at that in the case of your experiment. Fair tests allow us to compare a change and see if it's made a difference. That's essentially what a fair test is. Now in the case of our machine here, we've made a machine, we've measured the kinetic energy of the car to see how much energy it has before it pops the balloon. Now if you make a change here that makes it better, then essentially you're going to be measuring and seeing if that kinetic energy in your car the next time after the change, whether that kinetic energy is more than it was before. The thing that we measure to compare our different machines is called our dependent variable. The thing that we measure to compare our different machines. Okay? And in this case we're measuring several things. We're measuring the mass, the distance and the time in order to figure out its kinetic energy. But that's what we're measuring to see if our improvements have worked. That's our dependent variable. Your independent variable is the thing that you have changed, hoping it will make what you measure better. Okay, so it depends on what you change. I could change the slope of this ramp here, make it steeper. I could change the size of the ball here that I'm going to hit the car with. I could change a whole heap of different things. But the fact is you have to figure out what you want to change in order to see if it makes it better. Now if I changed both of these at once, then how would I know if it did make it better, which one actually worked the best? The fact is I wouldn't, because I'd have too many changes, too many variables changing at once. For a fair test, you can only change one thing at a time. The thing that you've changed is called your independent variable. So if I decide to only change the slope of my ramp, then I need to keep everything else exactly as it was before if I'm to know if changing that slope helped or not. That is my independent variable. Then we get down to this last thing here, the control variables. Remember how we said that changing the size of the ball as well is going to most probably affect the car? Well, any other variable or anything that can be changed in this machine that will also affect the car's kinetic energy, in order to make it a fair test, you have to keep those things exactly the same. I can't change the mass of that ball. I can't change anything else here. I have to keep everything else exactly the same to make it a fair test. Anything you need to keep the same so that it makes it a fair test is what we call a controlled variable. So I've written here anything you need to keep the same or remove, I'll explain that in a second, to make sure that the only thing affecting your car or its dependent variable is the change that you've made. Now I've said here remove because there are some things that we actually just remove entirely to try and keep our tests fair. And I'm not talking about things on your machine. Think about the environment that you're actually testing in. If you're testing in a windy environment, that's going to change the way the balls and that travel down through your machine. So you would remove that control variable by simply taking your machine inside and making sure when you test it, it's in a wind-free environment. So things like that you can actually remove from the equation so they don't affect your test are also control variables. So when you plan this next part of your experiment, you're going to be identifying different changes you want to make, but then you have to test each one separately to see if they affect the kinetic energy and how much they've affected the kinetic energy by. You can't make more than one change at a time.